Hello everyone, this is Gayatri Priya, Assistant Professor in the Department of EC. In today's VLSI design session, we are just going to discuss about the FPGA routing architecture. Right. So we have seen various types of routing architectures. So actually the routing architecture comprises of programmable switches and programmable wires. Basically, the type of routing architecture decides the area consumed by the routing and how far the logic blocks are present. That is, it depends upon the density of the logic blocks as well as the area consumed by routing. Right. So, what is a wire segment in the sense? It actually describes two endpoints of an interconnect with no programmable switch in between them. If there is no programmable switch, then that is being represented by a wire segment. We are having totally three categories of FPGA routing architecture. One is for Xilinx, the other one is Actel, and the third one is going to be Ultra. Let us see to the architecture, routing architecture one by one. First of all, let us discuss about the Xilinx routing architecture. Okay, so this is the diagram for Xilinx routing architecture. In this, LB stands for logic block. Okay, so we are having the horizontal as well as the vertical connections. So the internal connection is being magnified as given here for our quiet references. Right? So the horizontal lines are called general purpose interconnect, and these are called switch block, where we are going to make the routing switch. Okay, so each and every logical block is being interlocked to a switch block. Okay, so everything is being connected by a router. Okay, so whenever if I want to make a switch over, we will be making use of this routing switch to take over the control in case of your Xilinx routing architecture. So coming to the Actel routing architecture, it has more wire segments in horizontal direction when compared to that of the vertical direction, right? So this is the architecture diagram of Actel. Okay, here LB stands for logical block, and this is called the input segment, and this line side indicates the output segments. Here we will be having a clock track, separate clock track, and these lines are called the vertical track, right? So here each and everything are being interlocked by the wire segments, okay, which interconnects the input as well as the output segments. These are being interconnected using the wire components. Coming to the ultra routing architecture, here we are having a generalized structure called global interconnect structure, which is called as programmable interconnect array. So these programmable interconnect array, that is PIA, is used to make the connection between the lab, that is logical array block, right? So the advantage of this ultra routing architecture is that compared to that of the Xilinx and Actel routing architecture, it possesses a regularity of physical design of silicon which are being packed tightly as well as efficiently. So here comes the architectural diagram of Ultra. Okay, here the logical array block are being interlocked using the local bus, and even you can have a global routing architecture as well as the local routing architecture. So compared to the Xilinx and Actel, here you could see regularity in the design as well as the components are being very tightly packed. Okay, so a very detailed description of such routing architecture will be dealt in the forthcoming session. Thank you.